Quadratic Equations, Level 1. In the following series of videos, we will cover the various methods and techniques required to solve quadratic equations. Recall that a quadratic equation is an equation of the form ax squared plus bx plus c equals 0, where a and b are coefficients and c is a constant. In addition, a cannot equal to 0. A quadratic equation is a specific type of polynomial. It is also known as a polynomial equation of degree 2, or a second-degree polynomial equation. Lastly, it is also known as a second-order polynomial equation. All of these names describe the same type of polynomial. Notice that a quadratic equation tends to have three terms. The term ax squared is a quadratic term, or second-degree term. This term is the reason why this polynomial is quadratic in form. This is why a cannot equal 0. Because if a was to equal 0, this term will disappear and you're left with a polynomial that is not quadratic in form. Notice that this term contains a variable that is raised to the power of 2. Also notice that this is the term that contains the highest power of any of the three remaining terms. This is a telltale sign that you're dealing with a polynomial that is quadratic in form. In the same manner, the term bx is a linear term, or first-degree term, because the power on the variable x is equal to 1. Even though it's not explicitly shown, the variable is implied to be raised to the power of 1. And finally, the term c is a constant term, or the zero-degree term, because the power of the variable is equal to 0. And this results in x raised to the power of 0, which is equal to 1, which is then multiplied by the constant and simplifies to the constant c. Quadratic equations do not always contain three terms. For the most part, there are three types of quadratic equations. They include quadratic monomials, such as 2x squared equals 0, quadratic binomials, such as negative x squared minus 4 equals 0, and negative 5x squared plus 2x equals 0, and quadratic trinomials, such as 3x squared plus 2x plus 4 equals 0. Notice that a common characteristic of each quadratic equation is the fact that there exists a term that contains a variable raised to the power of 2, and it's also the highest power that is found out of all the terms. Remember, this is the defining characteristic of a quadratic equation. Specifically, the polynomial must contain a power function of degree 2, in other words, an x squared term, and this power must be the highest out of the remaining terms. Now let's talk about the standard form of a quadratic equation. When solving quadratic equations, we tend to organize the terms in an order suitable for solving. We usually want to organize or rewrite the polynomial in descending order, and equal to 0. For example, the following quadratic trinomial is not in standard form. 4 minus 4x plus x squared equals 0. From left to right, the degree or order of each term is 0, 1, and 2 respectively. We want it in descending order, so we need to rewrite and organize it as follows. X squared minus 4x plus 4 equals 0. Notice that the degree is now written in descending order. From left to right, it's 2, 1, and 0. This is the form you want to organize all your quadratic equations before you start solving them. In the same manner, the following quadratic binomials are not in standard form. 5 plus 5x squared equals 0, and 9x minus 2x squared equals 0. The degrees of the first quadratic equation are, from left to right, 0 and 2 respectively. So we want to organize them with the degrees arranged from 2 to 0 respectively, as follows. 5x squared plus 5 equals 0. Likewise, the degree on the second quadratic binomial are arranged from 1 to 2 respectively. So we want the terms organized with degrees arranged from 2 to 1 respectively, as follows. Negative 2x squared plus 9x equals 0. And finally, for quadratic monomials, there is no need to organize it, since it only contains a term of degree 2, such as 2x squared equals 0. Alright, now let's talk about what it means to solve for a quadratic equation. Recall that when you solve an equation such as the linear equation 2x plus 4 equals 0, also known as a polynomial equation of degree 1 because the highest degree of the polynomial is 1, and linear because when you graph the left-hand side of the equation, you generate a line. Let's go ahead and actually graph it. Noticing that the left-hand side of the equation is nothing more than a line of the form y equals mx plus b, where m is the slope and b is the y-intercept. In this case, our slope is equal to 2, and our y-intercept is equal to positive 4. When you're solving any equation in algebra, you're actually trying to figure out where a specific function, in this case the line 2x plus 4, is equal to 0. In other words, where does it cross the x-axis? So looking at our graph, it seems that this occurs when x equals -2. So let's actually solve this equation using algebraic techniques as opposed to graphical techniques. So we subtract 4 from both sides as follows. Then we divide by 2 on both sides to solve for x, which ends up being equal to -2. This represents the point in which the graph of the line intersects the x-axis, specifically at -2, 0. Now let's actually talk about quadratic equations. When we graph quadratic equations, they usually have the following form. This U-shaped form is called a parabola. And just like the lines, which contain positive and negative slopes, parabolas can open upward or downwards. We will learn how to graph parabolas in a later video. For now, I want you to understand how quadratic functions look like when you graph them. Whenever you are solving quadratic equations or any equation in algebra, you're always looking for the value of x that will make the equation equal to 0. In other words, you're looking for the x-intercept of the function when graphed. Now this is where the similarities between lines and quadratics end. When we graph lines, they always intersect the x-axis once, hence linear equations have one solution. But when dealing with quadratics, you always have two solutions. The graph of quadratic polynomials can look like this, where the parabola can cross the x-axis twice, hence you have two real solutions. Or it can touch the axis once, like this. In this case, you still have two solutions. This is what is called a repeated solution. More about this later. And lastly, the graph of a quadratic can look like this, where it does not cross the x-axis whatsoever. In this case, you have no real solutions, but you do have complex or imaginary solutions. In either case, you always have two solutions when solving quadratic equations. So make sure you keep this detail in mind when we start solving quadratic equations. Alright, in our next video, we will start solving quadratic monomials and binomials.